when there is an upward acceleration, there must be a net force. Alright? So I've written here that this double arrow, I use it to signify acceleration. So I'll write down that the acceleration is upwards. Okay? The acceleration is upwards. Alright? Now, this guy here is experiencing some external forces that has caused him to be in this cartoonish shape. Okay? But let's think about it. Is his weight changing? No. So if I were to draw a center of mass, center of gravity here, and I start, alright, I would say that his W is same as the first scenario. You cannot suddenly increase your mass. Correct? So in this case, the W weight is the same. Now, because there is an acceleration upward, can you tell me what is the direction of the net force? Because the acceleration is upward, what is the direction of the net force? Kiran, stand up lah, stand up. Do some exercise. What is the direction of the net force if the acceleration is upward? Huh? It has to be upward, right? Okay, because the lift is moving upward, so the net force must be up. So when we draw the normal, remember I'm talking about the normal on the human being, on this person, he will experience something that is longer than the W. So that is why I write there that the force net has to be, that is upward, has to be greater than the force of due to the weight. Okay, this is actually W lah. Huh? Okay, has to be the case. This has to be bigger than that. Then we get an acceleration. Clear? Okay. So what's the next thing we try to connect? This one here is your normal force, right? This one here is your W, right? And then we want to find out what is the net, right? So how we connect the three forces? Okay, so the force, the net force here has to be equal to the normal force minus the weight. Okay, only when you have this normal force minusing the weight will you get your net force. Do you understand that? Okay, so this weight is already provided because he has a mass of 140. And we know that we calculate weight by taking a mass multiplied by 9.81. Yeah, so we would just write there minus 140 times 9.81, right? And how do we calculate the normal force? The normal force is what we are trying to find out. If we can find out how much force the floor is acting on the person, we will know his apparent weight lah. You understand? And over here is your net force. Now the net force is therefore related to MA, and A is given to be 4.12. So you would just write down MA there. Now the mass has to be the mass of the person, right? So it will be 140 multiplied by 4.12 equals to, alright, no, then your, this one, and this I mentioned earlier is your apparent weight, okay, minus this, okay. So the apparent weight is simply this plus that value. Can you work it out? Can you calculate the apparent weight? Okay, remember, the apparent weight is determined by the normal reaction on the human. Okay, so what is my weight now? Take my mass, multiply by G. But actually, you are also calculating the normal reaction of the floor on your body, right? It's the same and equal. But whenever the lift is said to be accelerating upwards, the floor is now pushing on the human being. When the floor pushes on the human being, the human being is pushing on the floor. So the apparent weight now is greater than the actual weight. Understand? So that is why when you have this relationship and you calculate your reaction force, you are indirectly or directly also calculating your apparent weight lah. The reaction force is the floor acting on the human, on the person, which is equal to the apparent weight.